Hello, colleagues. My name is Dmytro Lendel, Uzhhorod National University, and I am glad to present our research, video promotion detection by fragment processing. The video data amount and its quality are increasing every year. Processing a large volume of information is a challenge for modern information system and in almost all classes of tasks. Probably science, the surveillance of cameras appearance, motion detection and motion tracking remain the most relevant ones. Modern approaches consider motion detection and motion tracking for various tasks. Traffic flow control, security cameras motion detection, object tracking, multiply object tracking, spot control system and so on. Motion detection and video can be approached using various methods and algorithms. Background subtraction, frame differencing, optical flow, temporal differencing, motion history images, deep learning-based methods, age detection. Each of their methods has a strength and limitations. For example, background subtraction is well suited for static cameras and stable backgrounds, while optical flow can detect motion even in complex condition, but it's more computational intensive. In the context of solving the motion detection issue, the ability to skip the step of matrix transformation to a square dimension or vectorization using some descriptor allow reducing computational costs, freeing up computational resources required for this transformation, and making it look worthwhile. In our study, we used key-fun norm value as an image frame block descriptor. The key-fun norm is built on top of matrix singular values. A singular decomposition doesn't not impose restriction or either the dimensional or character of the elements of the original matrix. As a result, we can migrate from non-square block to frame description square matrix. The SVD is powerful and robust mathematical tool, often used in a signal and image processing, computer vision, pattern recognition, fragment analysis, and other areas. The SVD transformation result is the three matrices. In our study, we used matrix S that includes singular values. The SVD is related to many common matrix norms and provide an efficient method to calculate them. It follows from our extents the sum first k singular values is a matrix norm called key-fun K norm. SVD does not require source matrix to be square, which makes it easily applicable for video processing. The point is that support of matrices of any dimensional gives flexibility in the source data representation. Technical to represent video frames can be based even on source image as well as any composition of descriptor without additional transformations. In this section, we will consider the result provided by the developed application. In our experiment, we used a video surveillance camera Hikvision. The camera was installed on office building parking and walked the whole day. The first step is to represent the source videos as a sequence of frames. Each frame is converted from RGB to grayscale model so that the value of each pixel carries only intensity information. Those problems associated with the color rendering and color representation are excluded from consideration. Practically means that we will be working in an intensive domain. As a result, the change in illumination will affect our experiment and we will measure this change by SVD. In the context of solving video surveillance, we can detect new object in a frame and follow object motion by fluctuation of signal values in the fragments. The result of frame-by-frame processing is a new video source in a grayscale model with marked blocks, which is shown on the right side of the slide. Each block contains the following data: key-fun norm value, key-fun norm middle value for the last X frames, and deviation from the threshold. Two blocks zoom it in and can illustrate the result in a better way. White spot is marked fragment that was determined as a motion area. proposed approach is based on comparing the Kifan norm value with the middle value of the last X frames. If the difference exceeds threshold, we consider that scene changed or movement has been occurred in the fragment. We selected fragment number 83 for the result demonstration in details. Fragment order is from left to right and from top to bottom. Fragment number 83 marked by yellow frame. You can see it on the left side. Fluctuation of Kifan norm and motion detection result is shown in a figure on the right side. We compare Kifan norm value to the middle value for the last 20 frames. The experiment has established that the deviation from the threshold value should be within 1–3% for object motion detection. Table below contains Kifan norm values for the last 20 frames, and on the frame number 90, Kifan norm value exceeds threshold and movement has been detected. We can detect Kifan norm fluctuation in any fragment, and if the value will exceed the threshold, we can confirm movement in this fragment. By combining the fragments in which the norm value has changed, we can build a graph of the object's movement. As a result, we can track the way of the person on the parking. In our video source, the man stared down, crossed parking, and reached the car. White spots marked fragments with extreme values. Natural lighting is variable. The sun's rays, the movement of clouds, lead to change in the illumination of different fragments. Unstable illumination will provide motion detection in the fragments without scene change or motion or object motion. Our approach has to exclude such fragments from the motion graphs. We need to select only neighboring fragments because the motion object will cross only fragment with a common border. Any other fragments have to exclude it from our track. We can apply a square filter 3 to 3, which will determine neighboring fragments with a motion tracking graph. Fragment 38 will exclude from motion track because the neighboring fragments in a filter frame. Fragments 84 will apply in a motion track because the fragment 83 and 73 are neighbors. You can see the motion tracking before filtering on the top right side. Filtering result is shown on the bottom right side. It should be noted that the filtering basing on neighboring fragments can apply it when there is one moving object in a frame. Our approach will not answer the question of which object is moving. The combination of fragment analysis and SVD allows finding fragments of the frame that could serve as a region of interest, and to which a more relatable algorithm could be applied. In our study, Kifan norm matching based SVD covariance descriptor for motion detection and motion tracking was proposed. Methodology describes the SVD generation of the region covariance as a tracking feature. Experimental results demonstrate the effectiveness and prospect of our approach. The choice of fragments count depends on size of the motion detection interest area. The object size in relation in a fragment size affects the number of fragments will be identified as a motion detection region. If the object size covers several fragments, the motion detection will establish in all their fragments. In addition, it should be noted that the number of fragments will affect the motion detection threshold value. The low cost of SVD and the absence of additional computational make our approach simple and efficient, which name it as pre-motion detect. Thank you very much.